Hello and welcome to the LINBIT community meeting. My name is Michael, and if this is your first time with us, this is an open community meeting where every quarter we open the meeting to the public, where you'll receive updates about our latest LINBIT software developments and have the opportunity to get answers to any of your pressing questions that you may have. At the end of each section, we will have a quick Q&A session. So if you have any questions, get ready and then have those in the Zoom chat, the YouTube chat, or just directly in Zoom if you prefer. So let's get the ball rolling with some developer spotlights to find out about all the work that's being done here at LINBIT. You know, balance is an important component in life. Whether that's a balanced diet or load balancing the TCP transport for DRBD, it's important. Phil is joining us to talk about this. Well, the TCP transport for DRBD, not the diet part. Phil, the floor is yours.
Thank you, Michael. Yes, then let me share my screen and just right into it. Share screen, here's the button. Okay. I hope screen sharing is coming through. Okay,
That's good.
Then let's start. So I'm working here on this feature, load balanced TCP transport, and it's pretty far in development. And let's walk through this DRBD resource config file. So it's the usual resource, and it has a name R0, and nothing unusual here. And I want to direct your attention to this statement. So with that, we select this new transport implementation. And apart from that, you notice that in the connections between two hosts, we always have two paths. And I have here just the same IP addresses and different ports. On a real hardware setup, you would also use here different IP addresses. Maybe you would use two different NICs into two different switches, etc. And when I activate that, so I have here the usual DRBD setup status output. You don't notice anything of that in here, but here we also have the socket start, the established TCP connections. And here we can see that to the peer 46, we have this connection, and where's the other one? And this connection. And the way backwards, and one more. So it needs to be 4. So, so this is because DRBD always establishes one TCP connection for data and one for control. And with the traditional TCP transport, you would only have 2 established at one time. And with the new one, it establishes both paths concurrently, and it can then balance the traffic between the 2 established paths. And now I prepared here a small file command that will write 550 megabytes. And with a bit of luck, we will be able to see a send queue building up on 2 of them concurrently when it mirrors the data down to this I2 VM. This guy is a diskless node, so it will not receive all the traffic. And yes, you were able to see it. It was blinking here very quickly, and that showed us, oh yes, it was using both connections. So what can you use that for? You can use that to combine the bandwidth of multiple network interfaces, and this is implemented on TCP level. And another possible application is if you happen to deploy your VMs in a cloud and the cloud provider limits the bandwidth of individual TCP connections, then you can go through just one NIC, but use multiple TCP connections. And with that, you will be able to aggregate the bandwidth. And it is the case that just the, let's say, world dominating cloud provider for infrastructure as a service VMs happens to do exactly that. They limit the bandwidth in a single TCP connection. By using multiple of those, you can aggregate this bandwidth. That's it for my demo today. And with that, I hand back to you.
Thank you. Are there any questions related to this particular topic? All right. If you have any, feel free to leave them in the chat. We'll get back to them later in the meeting. So next up, we're going to talk about network management because it's not always simple. You know, it's not a simple process, but Roland will be joining us to talk about a simple network management protocol subagent for DRBD. Roland, the floor is yours.
Yeah, thanks, Michael. So before I give you a quick demo and dive into the actual SNMP stuff, some 1 minute introduction to DRBD Reactor, because some people might not be familiar with it. So it's a daemon written in Rust that has several plugins that handle all kinds of things related to DRBD events. For example, there's a plugin where you can specify DRBD state transitions you're interested in, and then the plugin calls some user-defined script. Like whenever primary goes to secondary, it calls a script that sends you a notification in a Slack channel, for example. Then we already have the promoter plugin that promotes a DRBD resource to primary, if that is possible, and then executes a series of systemd units, which makes it basically a cluster manager. And we, for example, use that to make Linster controllers highly available, and we use it in vSAN. Then we have a Prometheus plugin that provides a Prometheus endpoint, and over that we export several DRBD statistics, which we use, for example, in our container images for our Kubernetes customers. And now we have a so-called Agent X plugin that allows us to do SNMP. Because, yeah, SNMP, it's old but still alive, and customers requested it, so we implemented it. So what is Agent X even? It stands for Agent Extensibility Protocol, which is a standardized protocol. And it is used between the so-called master agent, which would be your SNMP daemon, and a sub-agent, for example, ours, that provides DRBD metrics. So the question is, why not implement directly some SNMP sub-agent? Because SNMP itself is horribly complicated, and the library support for Rust isn't that great. And on the other hand, unfortunately, there was also no Agent X library for Rust, but we wrote one, and that one will be open source and public very soon. And yeah, that allows us to write the new plugin for SNMP support, and that's what I'm going to show. Share screen, I think it's that window. Okay, do you see the window?
Yep.
Yep. Okay, perfect. So that's on one of our internal cluster nodes. And first thing you need to do is to enable this Agent X protocol for your SNMP daemon, like so. It's very small what you actually need. You need to tell it master Agent X so that it's open. And then you need to tell it the Agent X socket, which is some address. And with that, you can run the daemon. And that's what I already did. And it's here in this Windows 0, switching back to Windows 1, where DRBD Director comes into play. Now there's a new type of plugin, which is Agent X. It doesn't have a lot of options because it doesn't need them. So you can specify the address of the master agent, which is the SNMPD. You can give it a number of seconds, and for that amount of time, it holds the cache. I think I will decrease that a bit because 2 minutes sounds a bit long, but that's details. It's just a prototype for now. And you can specify if it should show the peer states. Then if you are into SNMP, then you will know that all the data that is exported has to be specified in a so-called MIB database. It's just a text file, but there you list what your agent is going to export, what data type that is, and yeah, if there are tables, whatever, all the data structures. That's not what I was looking for. That's what I was looking for. That's a standard tool that allows you to show this database configuration, that MIB. In that case, we just load all the modules, ours included, and then we show the LINBIT module. And there you see, yeah, in this LINBIT module, we have some DRBD data. There's a DRBD table that is indexed by minor numbers. And then we have all kinds of statistics we export in this plugin. We will see that a bit in a better view in a minute. But that's what you also need, so that, yeah, SNMP knows what data it gets. So I'm now manually starting DRBD Reactor. Of course, you would just have that as a systemd unit, but for demo purposes, starting this thing. On Windows 0, we now see, yeah, it opened the session, registered itself, and now we can actually query some SNMP data. There is this SNMP table command, where we again say load all the MIB definitions, some SNMP stuff, connect to localhost, connect to the enterprises namespace, connect to LINBIT, and the rest is the place where we store this information table. Pipe it through less -s because the table is rather huge. So we need some space, and yeah, that's how it looks like. You have all the information you probably would expect, indexed by minor. You have the resource name, so that's our internal Open Nebula cluster, obviously. Resource name, resource roles. Is the resource suspended, right ordering? Can it be promoted? The promotion score, the disk state, is it up to date or diskless? What kind of volume, the backing devices, Is it a client? Has it quorum? The size? All that kind of things. How much was read and written to this? Blocked, and all the peer states, like the resource has, for example, 3 peers. And is how many peers are in this class state. So that's basically really enumerating all the possible states. But that's it. And it works. It's in a already good shape. I think I will release release candidate 1 in, I would say, maximum a week from now. And all people interested in SNMP, please check it out, take a look. Also take a look at the MIB. Is there something that is missing or something that you think should be presented in another way? Then please tell us. What will also be added is like a second namespace, so to say, where we also export some metadata, like what's the DRBD kernel module version that is running on the host, what's the DRBD utils version that is running on the host. That's still a to-do, but that's all minor things. And yeah, in the future you will be able to do SNMP and get some DRBD statistics out of it.
Nice. Are there any questions related to SNMP for DRBD? All right. If you have any questions, feel free to leave them in the chat or in the comments after this post, and we'll get to them. But for now, let's back up a bit so Gabor can join us and get in line to talk about queues for backup shipping and database importing and exporting. Gabor, the floor is yours.
Thank you. So let me share my screen first. All right. So as already introduced, we have released a few versions ago in LINSTOR the ability to create backups, to send them to S3 or to a different LINSTOR cluster. But we quite we received immediately feedback that creating too many backups might overload the network and create some issues. So we had to address this issue. But let me start with my current setup. I have a single node with a few small resources, so nothing too spectacular, but just for completeness sake, I have also limited the network traffic, the network speed. So even if these are very small resources, it will take quite a while to send them to NES3, but this is due to an artificial slowdown. Sorry, that was the wrong command. Let me use my cheat sheet instead. So this is what it currently looks like, or with the old version without having anything spectacular configured. If you create 5 backups, or want to create backups of 5 resources, to be more precise, as we can see here, every backup is immediately started, and this is exactly the scenario where customers and users gave us feedback that this might overload the network and cause a few issues. So I guess we don't really have to wait until this finishes. So let me interrupt this and just abort the snapshots because we don't need them. This is just the overall problem which we wanted to solve. And yeah, as you can see, the artificial network slowing already shows, even if in a smaller setup, maybe I slowed it down too much, but okay. So this is how things went until now. Come on. No. Please support it. Thank you. All right. Now we got rid of all of them. So this new limitation we introduced is a property with a quite self-explanatory name, max concurrent backups per node. It can be set on either a node level or on a controller level, which would affect every satellite, obviously. So if I now set this parameter to, or this property to 2, and repeat the create statement, we should be not really surprised by the fact that only 2 of them get now started. And the other ones, we go into this new queue for this particular satellite. Every satellite has its own queue, so you can play around with this property for each satellite individually, and they will just start as 3 shipment slots are left. So can we get started? Thank you. So another point is that you can also change this parameter also while there are already backups in progress. This does not really, this will not abort any shipments, but it will also not start the next one because the new limit is 1, which apparently I had a good timing with it, but I don't want to wait this long. So let me just increase the speed limit, which I configured previously. So as we can see now, since I limited it to 1, it ships 1 by 1, and this already we also got feedback from customers who are using it that it really helped to manage the overloading of their network. So that's actually already it with the first part, with the queuing backups demo. The second part is a quite different topic, which is export and importing of databases. When exporting a database, we highly recommend to first stop the controller to ensure a consistent backup. So this is also what I'm going to do now. This is why the controller is no longer responding. And we have a new tool in the same folder as the usual controller and satellite binaries are. There is this new tool, which has exactly 2 new commands. We should usually also configure the configuration directory where the linstore.toml file is expected to be in, which is this in my case, and just some arbitrary file name where we want to have the exported DB file. So as we can see, the current installation was an etcd installation. And just to have some fun, I'm going to actually delete the actual data from the etcd, but not just that. We will also demonstrate another thing that you can do with the new feature. We simply switch from an etc database to a SQL-based database, or in this case, an H2 implementation of it. And we can run basically the very same command, but import the database. Again, we have to specify the configuration directory and from which database file we want to import it. What it does in the background is it migrates from 0 to the target version, throws away the data from the migration, and imports the actual data from the file. So in this way, we can guarantee that the scheme is restored properly, the data is applied, and if necessary, new migrations can be applied to the file itself, in case someone is interested. Sorry. Is plain JSON. So here it's LINQ2 code. Here we have the node entry. We have some storage pools. So yeah, this is plain JSON. Nothing spectacular. Feel free to play around with it. And as I said, there are no real limitations. You can switch to different database types on the fly with using a changed TOML file. And right, that's basically it. Let me just start the controller again to demonstrate that the data is actually there. So the controller is starting, and there we go. We have the snapshots back. Oh, right. I have to enter the passphrase so that we can also connect it to the S3 database, not database, but S3 storage to access the backups. All right, one thing that I forgot, obviously this whole backup queue is also applicable for Linster to Linster backups. So it doesn't matter if your remote target is an S3 remote, as in my case, or a different Linster cluster. That concludes both features.
Nice. We got a question in the YouTube chat from Bjorn. He's asking, when will it be available for Kubernetes etcd?
So if the question is if you can go from Kubernetes to etcd, then yes. Every combination from SQL, etcd, and Kubernetes, regardless if source or target is supported, it should work, yes.
Nice. Any other questions? Well, in that case, if someone has, you can leave it in the chat or in the comments, and we'll move on to the next topic. I tried to come up with a joke that's related to DRBD and kTLS encryption, but one was too hard to decipher. So Moritz, the floor is yours.
Thanks, Michael. So yeah, as already teased, we're talking a bit about encryption in DRBD, something which we haven't been able to do until now. You should be able to see my terminals right now. And yeah, so right now I just have a regular DRBD running, and I will just verify that what you may already know, that as of right now there's no basically encryption of the DRBD traffic. So whatever data you write to the DRBD device is sent plain text across the network. So let me start TCP dump here, and then let's start writing. So I'm just on this node, I'm just writing to the device, and on the other node, you can see the traffic is coming through in plain text without any. And so now let's stop that because it gets annoying real quick. And so what I have been working on is a new option for DRBD, which is by default enabled by just setting this TLS yes flag in your resource file. And let's do it also on this side. And then for now, I need to down both resources. And adjust them again. And now it's looking like a regular DRBD device again, but this time the encryption, the connection is encrypted, which we can verify by again checking TCP dump, and I'll run the same command again. And this time you see there's no obviously detectable plain text that I sent on the first node. Here it's all encrypted traffic. And yeah, so that's basically a demo of it working. The way it works internally is Linux had kind of support for automatic encryption and decryption of TLS for a long time now. So everything up, or I think RHEL 8 has it, also Ubuntu 20 something, all these kernels already supported. What was missing up until now is that you couldn't initiate the TLS connection from the kernel itself, but recent versions have enabled that, and we basically backported this one kernel module you need to initiate the TLS handshake. And you can actually see that the handshakes is still happening in user space. So there is a new daemon you need to run, which is called TLS HD, which is the handshake service for TLS consumers. And take a look at the logs. I've made the logs very verbose, but basically when you specify this or you want to enable encryption for DRBD, when the connection is created, it first hands off the connection to this TLSH daemon, which then does all the setting up of encryption with checking the certificates, checking that the other side is actually the node we want to connect with. And at the end, it responds that the handshake was successful, and then gives control of the connection back to DRBD, and then DRBD can just use it like any other transport. What's actually nice about this is, of course, it needs some more testing, but since modern CPUs have basically dedicated hardware to do all the encryption, have special instructions to do the encryptions, there is not a lot of additional overhead you would maybe expect to enable encryption. Yeah, and that's basically everything I wanted to show. Back to you, Michael.
Nice. Are there any questions for this particular topic? Okay. So if you have any questions later, if you're watching the completed stream, you can leave it in the comments. And let's move on to the next topic with Johannes. And they say that if you close a door, a window opens. And if for some reason you have to use Windows, we got you covered with WinDRBD. And Johannes is going to be talking about how to build it yourself with a 1.2 branch.
Thank you, Michael. Yeah, you already named it. Building WinDRBD from scratch was a very complicated process, and we are now for the WinDRBD 1.2 branch in the progress of re-engineering some parts of the WinDRBD source code. And I did this little presentation for you. Do you see my screen?
We do.
Yeah, okay, great. So let me start with the build process of Windows kernel drivers in general. For WinDRBD, we need to patch the original DRBD source. There are a couple of reasons. One is that DRBD uses some new compiler collection specific constructs, which are not supported by the Microsoft compiler. And yeah, after the patches are applied, the DRBD and WinDRBD compatibility layer are compiled and linked. This is just the same as in Linux, but some post-processing is required. For 64-bit Windows machines, so one has to sign the driver and generate a security catalog file, which is also created during the build process. And finally, the files are packaged into an installer, which then can be run on the Windows in order to install WinDRBD. So as you might know, you have for 1.1 WinDRBD, you have to set up a Linux box, a Windows box, then connect them together, then install some build dependencies. So it's all very complicated. We had a colleague from China who tried to do this, and he was actually very smart, but it took him 1 week until he gave up to do this. So there is something we should do about it. Yeah, and what also is a thing, I have to log into the Windows machine on the console, also on the graphical user interface. This is a limitation of the Samba implementation. Yeah, we already had that. The old solution is this. Yeah, now signing a driver and a cat file, there is open source utility which does this, but generating the security catalog file, the cat file, wasn't possible with open source software until now. There actually is a program, but this requires a Windows library and therefore has to be run under Windows. And yeah, and it's, since we can't compile via SSH, we cannot run the build process in our CI environment internally. And also the DRBD utils have to be compiled separately before. Now in the new solution, DRBD utils is just a submodule and gets built on the make process. Yeah, I wrote a small C program who does the generation of the cat file, which is required when loading the driver into the driver store. We are now for the 1.2 branch using a GCC-based compiler, so we save on patches. And yeah, lots of cleanups in the make file. It's just much cleaner now. And what we also did, because for building WinDRBD, we need a very complex build dependencies, like you have to install a Wine, you have to install 2 different cross compilers. So what we did is packaged everything into a Docker container and made it publicly available. So once you have Docker installed, in this example on Ubuntu, you just say make pull Docker, which pulls the Docker image, and make package in Docker. And after, depending on your hardware and network connection, 10 minutes, you have an installable self-extracting exe file. Yeah, we, of course, because it's a Linux-only solution, which doesn't require a Windows machine, we can build it in our continuous integration. And plus, we also save patches to the original DRBD source, which makes handling updates much easier. Yeah, and I think this is a great step forward, at least for me. It's maybe it doesn't sound so difficult, but if you know how it was built before, I think it's a huge step forward to how it should be. Yeah, I can switch to a terminal now. I just did a make clean on this. And yeah, I just say make and add version tag. Yeah, as you can see, it uses all processors of the machine. and compiles the package in a Docker container. And it's actually right now already compiling the DRBD utils. The WinDRBD itself should also be already be built and signed. And now you see that it's packaged into installable exe file, which also has the version number attached. So this file in the inner setup directory is what you want to copy to your Windows machine to install it. And I have to say that maybe I don't know for sure, but since the cut file generation didn't exist before for the open source platforms, I think this is the first time one can compile a Windows driver for 64-bit Windows with only open source tools. So yeah, this is, I'm not 100% sure, but I think we are the first to really also generate the catalog. Yeah, that's about it. Let me just show you real quick. It's already on GitHub. So if you select the WinDRBD 1.2 branch, you get very, very simple introduction into how to build it. You still, however, have to put your Windows box into test mode. This is because we are using a self-signed certificate. So if you want to have officially signed version by Microsoft, please talk to your LINBIT sales representative, and we will provide you with a matching version. That's all from my side. I'm handing it over back to Michael. Thank you very much for listening.
Thank you, Johannes. Are there any questions for this? No? All right, if you have any when you watch the finished stream, you can leave them in the comments. And we did get a question earlier in the show in between topics, so we're going to go back to that. Are there any updated comparisons between DRBD versus NVMe_fabrics? Who wants to take that one?
So here, I take that one. Because I think the question relates to this new DRBD transport. And yeah, so the new DRBD transport that is about, or it implements real multipathing over TCP. And in the NVMe-oF fabrics world, that's also possible. But when we talk about comparing these technologies, I think the main difference is, let's say we're looking at a virtualization environment and you have some hypervisors and you have, let's keep it simple, a single storage cluster, right? Then you could use NVMe-oF fabrics to connect all the hypervisors to your storage target. And one difference is if you use the NVMe-oF fabrics protocol, in case of a failover, it's a real failover. Failover in the sense that the initiator reconnects to the target. If you do the same with the DRBD protocol, a failover is just a retry of an IO request and doesn't require an IP address takeover and all that complexity. And the other aspect is if you use the DRBD protocol from the hypervisor to the storage nodes, you also get load balancing from the two storage nodes. And it's actually one network hop less, right? Because the write requests are sent from the hypervisor to both storage nodes concurrently, while in the NVMe-oF fabrics case, it would be NVMe-oF fabrics from the hypervisor to the first storage server, and then using DRBD from there to the second storage. So if I got the question right, that was my answer.
Awesome, awesome. Thank you, Phil. And before I pass it over to Nell to wrap it up, I actually just got a breaking news via phone call that it is Julia from the US support team's birthday today. So just to embarrass you a little bit, Julia, I'd like to say happy birthday from all of us here at LINBIT, and hope you have an amazing day. Take it away, Tanel.
All right. Well, thanks for joining us for the LINBIT community meeting. If you have any questions, feel free to post your questions in the YouTube comments, or you can contact the LINBIT experts directly. And if you're Julia, I assume you're going to send a message to Ryan about this. Also, be sure to like and subscribe to the LINBIT YouTube channel to learn more about LINBIT and our software. Thanks again for watching, and we'll see you in just a LINBIT.
Bye, guys.
Happy birthday. I'm just kidding.
Yeah, I don't think we're going to do that.
Bye, everyone.